Hey guys, welcome back to AlgoYogi. We are doing graph series and our next problem in the list is course schedule 4. But before you solve this problem, I would highly recommend that you go through course schedule 1 and course schedule 2 and then come on to course schedule 4. These problems are like exactly same, just some minor differences in the way the solution is asked. Course schedule, if you have already done it, it asks you to basically check if it is possible to take all these courses because they all have some prerequisites. Each course have some prerequisites. Then is it possible to complete the courses because there might be some cycle in the this course schedule that you have. Then course schedule second is asking you to print the order of the courses that you can take, because first you'll have to take the prerequisites and then you can basically take the other courses, and finally it's also asking like if you can actually take all the courses, and if you can, then print the order. Then let's find out what course schedule 4 is asking us. Let's go over here. So there are a total of num courses in university school that you have to take, labeled from 0 to num courses -1. Now you were given an array prerequisites where prerequisites I represents a pair A and B, indicates that you must take course A first if you want to take course B. Well, here in this problem they have just flipped these, a course and its prerequisite. In the other two problems they have mentioned for A and B you must take basically B before you take A, but here you're going to take A before you take B. Doesn't really matter. For example, the pair 0 and 1 indicates that you have to take 0 before you take 1. Now prerequisite can itself be indirect, because there might be a prerequisite that A has a prerequisite, B has a prerequisite C, then A also has a prerequisite C, right? That's what they have tried to explain it right here. Now you are also given an array queries. This is right here, queries, that also represents two pair values, where queries at J represents U and V. For the jth query, you should answer whether course U is a prerequisite of course V. Simple, right? Return the Boolean array answer where answer J is basically the answer to jth query. Simple. Let's understand. I have taken this example here. We have 5 num courses. So this is the number of courses. Then we have prerequisites, which of course have this pair of values A and B, that says that you have to take course A before you actually take course B. So I have converted that to a visual representation here, so we can just go over right here. So before you take course 0, you have to take course 1. This is what it says. So before you take course 0, then you must complete course 1. That was told us in the problem, that the pair A and B indicates that you must take A before you take B. The same way, you have to take 2 before you take course 0, then you have to take course 3 before you take course 1, you have to take course 4 before you take course 3. So remember, just see, like the arrow that I have represented, it goes opposite way, and the only reason is because to represent the prerequisite, I think this way is better, because you must finish the courses in this order in order to basically to be able to take course 0, because these all courses are prerequisite of course 0. So that's the way I have represented the outgoing edge going from B to A. All right, now these are the queries that's given to us, and we have to basically return Boolean value in place of these queries in the answer, checking if this value A is a prerequisite of 0. Now in this problem, can you tell me if 1 is the prerequisite of 0? Well, yes, that's true, because 1 is prerequisite of 0. And how about 3 and 4? Is 3 prerequisite of 4? No, this can be taken, so that's false. This can be taken in any order, right? Because this is not a 4 is not a prerequisite of, sorry, 3 is not a prerequisite of 4. This is what I'm trying to say. Yes, that clicked, of course. So now, Siri, you can go away. Siri, just go away. All right, sorry about that. Then we have 2 and 0. Now is 2 prerequisite of 0? Yes, this is also true. So this is true, this is false, this is true. This is what we will be returning as an answer. Now let's go over the solution, how we will be doing it. If you have already solved course schedule 1 and course schedule 2, you will know how easy this will become. Just a little minor differences. First step is to basically create the graph adjacency list that we will do right now. So let's create graph adjacency list. So this will go like this. We will create graph adjacency list for each node 0, 1, 2, 3, 4. I want to have some gap. 3 and 4. We will create the array or list for each of these nodes neighbors, right? So 0 has the neighbor 1 and 2. Then 1 has the neighbor 3 and 4. 2 does not have neighbor, so this is empty. 3 has a neighbor 4. 4 does not have a neighbor. So these two do not have neighbor. These are the courses that you can actually take in any order. I mean, they do not have a prerequisite, right? So you don't need to take any courses before taking these two courses. Maybe these are the courses you actually start your session with or your semester with, and then these, once you are done, and these might be the prerequisite of other courses, and then you can take those courses. All right, that's how it should work in the school. Now, once we are done making this adjacency list, what I want to do is I want to have a set. Let's call it prerequisite. Prereq. I can just call it prereq. All right. Prereq will be a set of for each node. The set of node, we will be updating this constantly. We will be adding to these lists. What we are really trying to create is for each node, we are trying to create a set, which the set is the list of nodes which are prerequisite of that particular node. All right, and we will do that while we basically explore our this graph, this adjacency list, you can say. So I'll push this right here, okay, so that you can see. Now let's go over our graph. We're going to start exploring, then we'll be performing DFS. This problem is solved using DFS, and that's because once you start a course, you want to explore all its prerequisites, and while you are exploring those prerequisites, neighbors, in other way you can say, those prerequisites have other prerequisites. So before you finish these prerequisites, you have to finish other prerequisites of those courses. So what I'm trying to say, let's say we start exploring 0. That's the first course we want to start. So we're exploring it. It's being visited using DFS. Then we'll see what are the neighbors of 0. These are the two neighbors of 0. All right. So what I'll do in the beginning, I'll create a set for 0. And remember, it has been given to us that it's possible to take all the courses, so we don't have to worry about basically if it will be possible to take these courses or not. So this time we are not worried about if it will be possible to take the course. We're just answering the queries, is A a prerequisite of B? That's it. So now, if you can see right here, let's choose the neighbor 1 to visit. Then I'm going to start visiting 1. And remember, these are the list or set I'm creating here. So I'll create an empty set in the beginning, and then I'll start adding the neighbor of 0. So first to 0, I will add 1 as its neighbor, 1 as its prerequisite or neighbor, you can say. And because I'm exploring this 0, I will also be adding or updating this particular right here, this key, with other values that I find will be prerequisite of its prerequisite. That should click. Okay, so now I'm exploring 1. I will add 1 to my prereq. Then I'm going to start exploring its neighbors. So first I will add 3 to itself, 3 to its neighbors. But then because I'm going to start exploring 3, 3 will have its own set, own prereq set. Right, then let's explore 3's neighbors, which is 4. So I will add 4 as 3's neighbor. Then remember, this 4 right here is now neighbor of 3 as well. But I guess at this point it would be better we explore with the flow of DFS, and once we return, we will add those values, update those values to basically to my that parent node that called that DFS. So right now we're exploring. So now I'm going to start exploring 4. 4 does not have any prerequisite. This will be empty. This will be empty, right? And then 4 will go back. Now because 4 is going back to 3, we already have added 4 to 3's prerequisite. Then we are going back to 1, but we will update these values. We will add 4 as well to the prerequisite of 1. All right, prerequisite of 1. Now 1 has one more neighbor, which is 4, directly as well, although indirectly. This was indirect, by the way. This was indirect prerequisite. 4 was prerequisite of 1 indirectly through 3, but here directly also 4 is prerequisite of 1. Then we'll go back, we'll circle back to where we were called from. So these are the nodes that we have already explored. So sorry, not 0, we haven't completed that. Then I'm going to start visiting 2. I will add 2 to my prereq list. Then I see 2 does not have any neighbors, so I'll basically come out. So 2 does not have any prerequisite, but then we go back to 0. We'll append 0 to, but if you remember here, we forgot to add 3 and 4 as dependency or prerequisite for 0 as well, because we'll add these values right there. Like 4 was added because it was part of one's neighbor or prerequisite. Then 0 is also completed. After adding 2, 0 is also completed. Now this is the set. This is the prerequisite set that we will be using. This is the set we will be using to answer all the queries. So now we have created the graph adjacency list. We run our DFS. We created this prerequisite map with a set of values that are prerequisite of each node. Now let me just clear this up. We will be running queries and we'll be building our answer set. So for our answer set, what we are going to do is we're going to go query by query. This is A and this is B, and what we are really checking, if you remember in the problem we were asked you should answer whether A is a prerequisite of B. So if 1 is a prerequisite of 0, 0 has a set, and we are checking if A exists in this set. For B, B are these values and A are these values. So we're gonna go one by one and check if A is in the set that is next to, in prerequisite next to that particular node, which is 0. So is 1 prerequisite of 0? Yes, it exists right here. So I'll add that to my answer. So I'll say true. So first query is true. All right. How about second query, which is 3 and 4? Is 3 a prerequisite of 4? So let's go to 3. If 3 is a prerequisite of, is 3 a prerequisite of 4? Yes. So let's go to 4. Yes, let's go to 4. And does 3 exist in 4? So the set, prerequisite set? No, it does not. There is no value in there. So I will mark it false. See, although 4 is a prerequisite of 3, but 3 is not the prerequisite of 4. Now, how about the next 2 and 0? So this is A and this is B. Is A present in B's values, set of values? So B is 0. 0 is right here. Is 2 present there? Yes, it is. So I'll mark this as true. And then this will be the answer, guys. This will be the answer that we will be returning in the end. All right. Now, time complexity for this problem. Time complexity will be, we can write here, time complexity will be big of V plus E. So using in our DFS, we are visiting all the nodes, which is all the nodes, and we are traversing all the edges right here. All right, so then it's V plus E, and the space complexity is also big of V plus E, and that's because we are storing all the nodes in our prerequisite set. And even while exploring DFS, there might be a case we actually utilize, while calling this DFS recursively, we might utilize that space, although it's not explicit state, it's explicit memory. It is something that, our algorithm is running on. All right, so now is the time to code up our solution. It was easy, pretty easy. Now let's write the solution, and we're gonna go step by step, and you'll find how easy it was for us to convert this code, understand the concept, and convert that code to basically convert that those concepts, our answer, to code. All right, so as I said, we will be creating a graph. Graph will be initially this, we're trying to create this adjacency list. So I is going to have empty list for I is a node in range num courses. All right, so num courses, just to check if we're not having any typo. Then let's fill it up. So so first is the prerequisite, must take a, so prerequisite and course in prerequisites. We are building this adjacency list. So to graph, I will add that for this course, we're gonna append pre as its prerequisites. All right, so there is an outgoing edge from course to prerequisites. All right, now what do we need now? We're gonna create this map that we said, so we will call it prereqs map, which will be empty in the beginning, and then for all the course in range num courses, not course, num courses, I'm going to run a DFS. We'll be exploring all the courses, so I'll run the DFS, and in the end I will create my answer set. That will be just with values that I'll be appending. And for all the queries, so for query a comma b in queries, remember we have not written DFS. This is where we will be writing. So write DFS here. So it will be DFS, which takes a course, and then we'll write this in a bit. Okay, we'll write it. Remember this pass keyword is basically you write when you have not completed the method, and you just whenever we call this method, then it passes back, like it just executing this method. So in queries, this is what we are answering. In queries, what I am checking is answer dot append. I'm appending a Boolean value if a is present in this prerequisite map that I'm creating, which will hold values in B, in the set that B key holds all the prerequisites. If A is present in B's list of prerequisites, that's what we are checking. And then finally we'll be returning this. We return our answer. All right, so let's go back to our main function, DFS. I'm telling you guys, like DFS is awesome. Okay, so if course is already present in my prereqs, if this value is already in, what am I doing? Oh my god. So yeah, if course in this prereq, that means I can just return all the values because this course has already been explored. Its prerequisites have already been calculated, and if you're trying to access it right now, then you can just return those list of values, so prerequisites values for this course. Then I'm gonna create like a temporary set here, temporary set where I will be adding all the neighbors or all the prerequisites that I will be exploring here. So this is how you will be doing for neighbors of or you can say prerequisites or neighbor in graph, and for course. So this is what you will be doing. So first you want to add that neighbor to your temporary set that you're creating. So I'll call it let's say temp set, temp prereq. Okay, so this is basically a set. Then to this set I want to add the neighbor, because that neighbor is the prerequisite for this course. Okay, this course that I'm currently exploring, working on, or whatsoever, right? Because if it's not already been explored, then I'm going to start exploration right here. I'm going to start visiting. It's being visited, which will have empty. It does not have explored any of its neighbors. Now it's exploring. So what I'll do, I will basically add that. So I'm adding that neighbor to basically my temporary set. Then there is one more thing. So at this neighbor, what I want to do, I'm going to run DFS, because before I find out all the prerequisites for this particular course, and this neighbor is the prerequisite of course, because we know it through this adjacency list, I'm going to explore all the prerequisites of neighbor as well, right? That's the whole point of DFS. So what I'll do is I will have DFS running on the neighbor. Now this will be returning some set of values. We have to add these values to our current course as well, because those values that have been explored along the way. So right here, this is the part where this is what I'm talking. So while exploring, while you are exploring 0, and then you started exploring 1, and 1 has to explore, because 1 is the neighbor of 0, and 1 had to explore 3, and 1 had to explore 4. Then these two values will be added. They are being added to the set of 1, but they need to be added to the set of this particular parent also. This is what we are doing right here. Okay, so this is what we are doing right here. So over here, what I'll do, this neighbor will bring some values. I want to add those values to the set of course as well. So what I'll do, this is bringing some values. I will have this temp prereq that I was creating for course. I will update it. So I'll do this set.update. So update will basically only add these values and not remove the neighbor that I have added, because this neighbor is a set, but this neighbor is bringing some other values that I'm adding. So I'm updating it now, right? I'm not overriding, I'm updating it. So these values will be added to what this value is already there. All right, then finally, once you have added basically those prerequisites to course, because current neighbor is a prerequisite of current course, and then whatever prerequisite it's going to bring, then we have added to our temp prerequisite. Then what I'll do is I'll add this whole group to basically my this prerequisite set right here. I will add those values. So for this course, the value will be this entire list, right? This entire list. Okay, and then I guess once I am done right here, then I can even return this. I can return this value as well. So I'll return for this course, because now I've built this, or you can just say even this as well, but like doesn't make a difference. All right, let's zoom out. I'm gonna zoom out. I'm not zooming out, so I'll have to just manually do it. Okay, so this is the entire code. Let's reduce some gap over here, so that we have nice and little kit, all of it together. Okay, so let's try to run it. Yes, it passes all the tests. Yes, now we're going to submit it. And awesome, that's a pretty efficient solution. Here's the entire code. I'm leaving the video kind of paused for a bit so that you can have a look. And then finally we're gonna write the time complexity. We already discussed this. It's going to be big of v plus e. V is the number of vertices, e is the number of edges, and same goes for space complexity. Because we are storing all of it into this temp prereq, prereq. All right, so space complexity will be also v plus e, number of edges and number of vertices. Alright guys, let's go back to AlgoYogi, mark this solved, and I hope there are no more course schedule problems because we have done pretty now. There might be one third problem because we have only done first, second, and fourth. So there might be one more. But anyways, we are an expert now, so I hope you were able to solve this and understand it. Bye-bye.